Hi guys, in this video we will learn about lists in Python.
The topics we will cover in this video are Introduction to Lists, Creating and Accessing Lists, List Operations, and List Functions and Methods.
So what are lists? Lists are containers that store values. Now these values can be of any data type. You can have numbers, you can have strings. Sometimes in your list you can even have combinations of values which are of different data types. For example, I can have a list which has strings, it can even have numbers, it can even have float, etc. Now a very important characteristic of lists is that lists are mutable. That is, if I want to change only one element in the list, I can do that. But then if you look at strings, they are immutable. Now how to create a list? So for creating a list, we'll use these square brackets. And like how in strings we used double quotes or single quote, we'll be using enclosing our values within these square brackets. And now, for example, these are examples of your lists. So this is a list of integers. This list you only have your strings. So hi is one element, hello is another element. Whereas look at this list. This list has three elements. All of them are of different data types. Like this is an integer, this is a float, this is a string. So list can have values which are of different data types. Now I want to access a particular element from a list. How do I do that? So before going into that, we need to understand that strings and lists are very similar. Like remember, for strings also we had indexing, we had forward indexing, and we had backward indexing. Similarly, we have the same thing for lists as well. Now here you can see list 1, and I have a list here, the same list I have here. But here the indexing is different and here the indexing is different. Here the indexing starts from left. So A will be 0 and the next position will be 1, 2, 3 like that. Whereas here the indexing starts from right and it is negative numbers. So -1, -2, -3 like that. I can access elements either using forward indexing or backward indexing. Supposing I want to access A, I can say list 1 of 0 and it'll give me A. If I want to access the same element using backward indexing, I can say list 1 of -5 and it will give me A. So here we are basically using the index. So these are called index for the particular element.
Let us look at list operations. The first operation is concatenation operation. So here I want to combine two lists together. So how will I do that? I will use the concatenation operator. Suppose in the example I have list 1 which has the elements 1, 2, 3, and the second list is having the elements 4, 5, 6. Now these elements are in two different lists. I want to bring all these elements together into one single list. The order has to be maintained. So whatever, suppose if I want 4, 5, 6, 1, 2, 3, then I'll say list 2 plus list 1. But here I want 1, 2, 3, 4, 5, 6. So I will say list 1 plus list 2. The elements in the list that you will specify in the end will be padded to the first list. Now let us look at replication operator. In replication operator, when I want to have the same set of elements in my list multiple number of times, I will use the replication operator. So here I have 1, 2 and 3. And I want this 1, 2, 3 to come say x number of times. So for that I'll use the replication operator. In this case I've specified the name of my list, which is list 1. I've used the replication operator and then I've specified 2. Now this 2 is specifying how many times I want these elements to be replicated. Now if you see the list, it says 1, 2, 3 and then 1, 2, 3 again. So that means these elements are repeated in the same order twice. So again the same thing. It's like, actually if you look at it, it's like doing list 1 plus list 1. So it's like concatenation operator but with the same list. I specify 3, it'll be 1, 2, 3, 1, 2, 3, 1, 2, 3. Now let us look at list slicing. So if you look at this list, you have the elements F, R, U, I, T. But I want only a piece or a slice of this list. So how do I do that? I'll use the technique of list slicing. So here I have to specify, and this is similar to what we did in strings. We had string slicing, exactly the same for list slicing. So I need to specify the name of the list, the start index and the stop index. So the start index, here I've said it's 1. So I will go to the start index, which is 1, And what is in the first index? I have the letter R. So I'll start with R and I have to go till 3. But I don't have to put the element which is present in the third index. So I only have to go till the third index, but I don't have to print this. So then what will be the answer? I'll start with 1. So R, then U, and then I've reached my limit. So I don't have to go here. So I'll only get R and U. Now I can also use backward indexing for list slicing. Now here I've said start from 1. So I go to 1 and I see R and end till -1. So go till -1. -1 is having the letter T. So I'll go till -1, but I won't include this. So then what will I print? I'll say R, I'll say U, I'll say I. So this is list slicing. Let us look at membership operators in lists. Now, why do I need membership operators? I need membership operator to check if a particular element is present in a list or if it's not present in a list. So the membership operators are in and not in. Now we'll take the same example as earlier, list 1 equal to fruit, and the first example I will be seeing if f is present in this list or not. So what is the syntax? First I'll specify the element that I'm checking, then the operator, which is in this case in, and the name of the list. So I'm saying a statement f is in the list. Yeah, f is actually in the list, so my answer will be true. Now if you look at this, I'm saying f not in list 1. So the syntax is the same as this, except here it's in and here it's not in. And then what is the answer? It's false, because yeah, f is actually in the list, and here I'm saying f is not in the list. So this is a false statement, so I will get the answer as false. Now let us look at list functions and methods. So why do I need functions? Whenever I want to perform certain actions on my list such that it changes the list, those actions will be performed using functions. So the first action or the first function we will be looking at is the dot append function, which is used to add an element to a list. So list 1 is this, and I want to add k in this list. The alphabet k or the element k I want to add into the list. So I'll say list 1. So the list name, dot append will be the function name, and then I will specify the element that I want to append into the list. So here it's k. Now what is the result? I'll get list 1 equal to fruit, which is the same as before, but now I have another element which is k over here. And remember, append is only used when you want to add one element to the list, and also you're always going to append the element at the end of the list. So you can't have your k anywhere here in the middle, 0th index or the first index or anything like that when you're using the append function. So it'll always be appended at the end. Now what if I want to add multiple elements to a list? So in that case I will use the extend function. So here I want to add k and I. So whenever I want to add multiple elements to a list, I need to pack these elements in another list, and then only I can add. Like here in this case, k and I, I'm not just writing k and I have to put this k and I in a list format, and this list is list 2, and then only I can use the extend function. Now in this case, you can see list 1 dot extend list 2. So it's in a list format, right? Now what is the result? You can see fruit, which is the same as before, and k and I. So these are the newly added elements. As how append works, same thing. The newly added elements are always added towards the end, not in the beginning or not in between or anything like that. Now I will have this doubt that every time I don't want to add element or multiple elements at the last location or at the end only. I want to insert wherever I want. Like I want to insert, if I want to insert in the second index, I should be able to do that. I should be able to insert it into any index I want. So for that we will be using the insert function. So here if you see, I want to insert element k, but I want to insert it in index 2. So how will I do that? I will specify the name of the list, specify the function insert, this 2 is the index where I want to put my k in, and the k is the element that I want to place inside this, insert inside the list. So what will be the answer? It will be fr, but you can see k. So 0, 1, 2. So in the second index, earlier I had u, but now I have k, and the other elements are pushed to the right.
Now let us look at how to remove element from a particular location in a list. For that we will be using the pop function. So this is my list and I want to remove an element in the index 2 in the list. So here for removing the element I have to specify the index. So list 1, which is the name of the list, dot pop the function, and inside these brackets I will specify the index. So what happens now? The result will be FRIT. So this U, which was earlier, which was there, is gone because U is in the second index. I asked to remove this from the list and now it's no longer there. Now what if I want to remove the element from a list, but I don't want to specify the index? So how will I do that? So in this list, you have FRUUT and I want to remove element U in the list. Now you will have the doubt that okay, there are two U's in this list. There's a U in the second index, there's a U in the third index. So which U will this consider? So the first U that you get, it will remove that U. Now here I'll say list1 dot remove U and it removes the first U and the other U is still remaining in the list. So the first occurrence of the particular element will be removed from your list and for that you will use the remove function. Now count. So this is the last function that we will be looking at. So count function is used to find out how many times an element is occurring in the list. For example, I have FRUUT in this list and I want to count how many times element U is occurring in this list. So for this I'll say list1 dot count, specify the element that I want to actually count and it will give me the answer 2 because yeah, U comes twice. It comes in the second index as well as the third index. Now let us try a few more examples. Before we look at examples in a list, I'll discuss an important concept about lists. So I have a list A equal to 1, 2, 3. Now this B and A, so what will this do? This will make B and A point to this list 1, 2, 3. And now if I say B, B will also be 1, 2, 3. So B and A are not separate lists. There's actually one list and B is pointing to this one list. A is also pointing to the same list. Now I'm going to change the 0th index element from this list. So I'm using A of 0 equal to 5. I print A, I'll get 5, 2, 3. Now what will happen if I print B? Now you see this change is reflected here as well. So this is the proof that B and A are not pointing to separate individual lists. They are pointing to one list and whenever any change is reflected, we're using any label that is pointing to that particular list, same change is reflected with B as well. So what if I don't want this change to happen? So what I should do is, I should say B equal to list of A. So now B is 5, 2, 3. A is 5, 2, 3. Now watch this. I am changing A of 0 equal to 6. So A is 6, 2, 3. But B will be 5, 2, 3. So you see the change is not being reflected here. So this is what we call as an independent copy. So any change reflected in A is not reflected in B. B is independent of A. So B is actually pointing to one list, A is pointing to another list. It just happens that in the beginning, these lists, both the lists had same elements in the same order. But once I make any change using the A label, I am not seeing that result in the B label. Now let us try a few functions. So two functions that I did not mention earlier were the reverse function. So now I know B is 5, 2, 3. So if I do B dot reverse and then I say B, I'll get 3, 2, 5. So it reverses exactly the opposite. So it says 3, 2, 5. Now this can also be done with another method. What is that? That is the list slicing method. So if I say B, so this is the same syntax as what we did for strings earlier. I just have to say B and then start and end index. You don't have to specify, just say -1. So the moment you give this sort of syntax, it will start from the end and it will start printing from the end. So here B was 3, 2, 5 and now it printed from the end. So 5, 2, 3. So what happens actually in B dot reverse is that it's like it's changing B itself. So no longer, now B was 5, 2, 3. After reversing, B became 3, 2, 5. Slicing, I am reversing it again. But it won't be reflected. It won't actually go and change. It'll just print it like, it'll just print the reverse, but it won't actually be reflected in the list. So only functions and methods you can do that. So another example, another function that I haven't mentioned before was sort. Now your list is 3, 2, 5 and I want to sort the elements in the list. So what is sorting? I want to put the elements in an increasing order. Like if I have the element 3, 2, 5, I want to put it in an order which is like 2, 3, 5. So 2 is less than 3 and 3 is less than 5. So you can see 2, 3, 5. So that's all for the session. Thanks for watching. Please like, share and subscribe.